Good morning, everyone. If you have an empty seat next to you, could you raise your hand? Okay, there's an empty seat here. I see one there, one there. If you're out in the hallway and want a seat, we've got people who can help guide you to the seat. So there's a seat right up front. There's one in the middle up here. I see one in the second row here. I really want folks to have to stand for this program. Well, anyway, welcome to the University of Michigan. Welcome to Ann Arbor. Congratulations. In a lot of respects, you've made it. You've done a lot to gain this opportunity. You've completed a challenging undergrad curriculum at your home institution, either here or elsewhere. You passed all those necessary exams. In some cases, you have completed a master's degree already, and now you have committed yourself to a decision that will consume much of your time, most of your energy, and probably a few dollars. But when you finish this adventure, you will have earned something special, a graduate degree from the University of Michigan's College of Engineering. And you're going to be very well prepared here to make a difference. I know that for fact, because I see that from all of our alums. Today the fun begins, and you can ask what lies ahead for you. Today you'll begin to discover the answer to that question. For each one of you, the answer will be different, but regardless of your field, I can assure you that your future will involve working hard to solve big problems, because that's what we think about here in Ann Arbor. We're thrilled you chose Michigan, and I don't think you're going to be disappointed. We are committed to helping you have a terrific experience here in Michigan Engineering. I'm sure you've done your homework and know a lot about the College of Engineering, especially if you were an undergrad here. This is a place that you're now going to be calling home for the next year and a half or 2 years, or maybe 3 years, or maybe 5 years, and I hope not 7 years. But for most of you, the university and Ann Arbor are new domains, and we want to make sure that every one of you has a common base of knowledge about our incredible creative community here. So let me take just a moment to highlight some of the many attributes of your new home. Our worldwide College of Engineering alumni network, and so this is just the engineering alums, not the university alums, is 70,000 strong, with active alumni ranging from recent graduates like Julia Samorazov, who was a PhD student at another institution, or Danny Shao, who works for Procter & Gamble. They just graduated a couple of years ago. But then we've got other alums, people like Chuck Hutchins, who is a 1957 graduate. He's one of our donors. He's a devoted fan of our solar car team. In fact, he travels with that team no matter where they compete, all across North America, Australia, you name it. But we have some very well-known college alumni. Larry Page, probably a familiar name, co-founder and CEO of Google. Tony Fadell, who actually led the team that invented the original iPod. Christine Spinicki is probably a name you're not familiar with. She is one of only 5 U.S. nuclear regulatory commissioners, all appointed by the President of the United States. Chuck Vest, who was one of MIT's longest-serving presidents, and then later was president of the National Academy of Engineering. Samuel Ting, who had an undergrad degree in engineering from Michigan and later went on to receive a Nobel Prize in physics. Our faculty have created many breakthroughs. Among them, the first lab on a chip to analyze DNA samples and report the results electronically. That device was created in collaboration with our wonderful medical school here on campus. Another faculty member has created with his students the world's fastest 2-legged robot that has knees, just like a human. The world's first reconfigurable machine tool. The world's most intense laser, where the peak power there is so high, it would take 60 times the average of all the world's electric power generating stations to supply that power if that laser did produce that pulse on a continuous basis. Of course, the secret is the pulse is really, really, really narrow. It's a picosecond pulse. But during that brief instant in time, the amount of power being deposited on a tiny spot is equivalent to 60 times the average power of all the world's power generating stations put together. We also are credited with the first application of activated carbon technology for the recovery and recycling of reusable water from industrial and municipal waste, and also the software program that became the basis for Photoshop. And I'm sure each of you knows about that software program for image processing. Today, the University of Michigan and Michigan Engineering remain a remarkable place. The University of Michigan has the largest research portfolio of any public university in the U.S. In fact, the only university that has a bigger number counts a federal lab as part of its research portfolio. Here in Ann Arbor, our research expenditures last year were $1.27 billion, and the College of Engineering accounted for about $200 million of that. The University of Michigan has 99 graduate programs ranked in the top 10 in the nation. Not many schools that can claim anything even close to that number. Michigan is one of only 2 universities in the nation that has top 10 rankings in engineering, medicine, and law. Within the College of Engineering, we have a number of recently established programs that are quite exciting. One is, I'll use the acronym CYGNSS, which stands for Cyclone Global Navigation Satellite System. This is a new project from NASA. Price tag is $152 million, and it is to design and build a constellation of satellites that will monitor wave action underneath a hurricane to predict the severity of hurricanes. It turns out the scientists have become very good at predicting where a hurricane will hit land, but are very poor still at predicting the severity of those storms. So we really need to be able to look underneath them and measure wave heights. We also have a Naval Engineering Education Center. This is led here in Ann Arbor. It was our idea. It's a consortium of 15 universities that are developing the Navy's future workforce through project-based education. We have a new master's in entrepreneurship, which is joint with the Ross School of Business here at Michigan. That's a special program because the courses are taught 50-50, half by engineering and half by business. It's the only program like it in the nation. We're also home on the entrepreneurial side to a program called the National Science Foundation I-Corps, where I stands for innovation. We were one of only 3 schools initially selected for this by NSF, the others being Stanford and Georgia Tech, to provide training for budding entrepreneurs. Current faculty members in the College of Engineering, and here it's a good thing most of my faculty are not here, so few people will be offended, so I'm only going to name a few. But some of our faculty members are the following. Joyce Penner, who is a member of the United Nations Intergovernmental Panel on Climate Change, and she was one of the many co-recipients of the Nobel Peace Prize in year 2007. Khalil Najafi and Ken Wise, who are pioneers in MEMS and microsystems. Victor Lee, who is a pioneer in bendable concrete, and you can see his work on the History Channel and also all over YouTube. We have 6 just very distinguished professors of engineering practice. These people are a little bit different from the typical faculty member. These kinds of faculty members have had very distinguished careers in government or industry, and then after completing that part of their career have moved here to the University of Michigan. One of those people is Jim Bajan. Jim has an undergrad degree in engineering, so he's an engineer. He has a medical degree. He's a member of both the National Academy of Engineering, which is the highest achievement in engineering. He's a member of the Institute of Medicine, which is the highest achievement in medicine. And on top of that, he's an astronaut. And he served on, this is a little bit of a sad thing, but it goes to Jim's expertise. He served on the recovery teams for both shuttle disasters. What's Jim working on now? You'd never guessed it. He's working on safety in hospitals, safety in clinical health settings, and making very major contributions there. Another one of our professors of engineering practice is Donald Winter. Don is a former Secretary of the Navy. Don knows things that you and I don't know. He used to have 1 million employees reporting to it, and so he brings a lot to the College of Engineering. Well, as a result of our continuing ambitions here in Ann Arbor to make a bigger difference, we are entering a period of transformation, I would say, a period with unprecedented efforts to collaborate with other units across campus and with other universities and with industry to tackle the world's biggest challenges in the years to come. One novel thing that we invented here, it doesn't exist at any other university, is a program called M-Cubed. The way M-Cubed works, and from the point of view of a faculty member in engineering, every faculty member was given a token that was worth $20,000. But they couldn't cash that token in unless they could find two other faculty members, at least one outside of engineering, who more wanted to work with them than with anybody else on an idea that they would propose. We developed a social networking website for the campus, so any faculty member in any discipline can propose a project on that website. Every other faculty member can see that. Actually, students can see it as well. And then once 3 faculty members decide to work together, we have a new verb around here, it's called cubing. They agree to work together, the money gets turned on instantly, and those faculty members hire a PhD student, or a master's student, or a postdoc to begin work on that project. And you may say, well, yeah, but so okay, that's some kind of seed funding program for research. A lot of schools have that. What's different about this? What's different about this is there is no review of the proposal idea. In fact, it would be hard to review because there is no proposal. There's simply an abstract posted on a website. Faculty members look at other ideas, and this is promoting an unbelievable amount of cross-fertilization of ideas on this campus. We have about 220 of these cubes, so about 660 faculty members working in this domain, and the program just launched last fall. So that's, it gives you an idea of something unique, the kind of unique things that occur here on this campus. If you've walked around campus a bit, you see a lot of construction up on Hayward. There's a big addition being added to the G.G. Brown building. That is for the Mechanical Engineering Department, and that is for a major national lab that will work at the interface of mechanical engineering and nanoscience and biology. As soon as that is finished, we're going to commence a large renovation of much of the G.G. Brown building. So if you're in mechanical engineering, you're going to have a really exciting time here. We'll have a lot of signs up to tell you which hallways to avoid and that sort of thing. But by the time we're done, you're going to see sparkling new facilities. But that's not all we're up to. Actually, the university is entering its next major fundraising campaign. It will be announced publicly on November 8th. I didn't really scoop you or anything on that. Other people know that. But in engineering, we're going to be launching the largest engineering fundraising campaign ever undertaken by any college of engineering in the nation. And our focuses are going to be on attacking big societal problems, on economic development and entrepreneurship, and very much on the student experience. You're going to be having incredible opportunities here that will help you make a difference. Through your research and how you creatively apply your knowledge, each of you is going to become a difference maker, and I hope even before you graduate. I could give you all kinds of examples of what our students are involved in. I'll mention just one. Paul Bita is a PhD student, and he's a president of an actually newer organization called Bridges to Prosperity. This last summer, Paul and a few of his best friends built a 25-meter pedestrian bridge in rural Bolivia to connect residents to a clinic, to a school, and markets. That's just an example, but our students are very involved in things outside the classroom, outside their programs of study, and also very involved internationally. As busy as you'll be, I hope you'll take some time to get to know the people in your program and to experience our broader campus. Some of your best memories are going to be the connections and ideas that you make with other people or create with other people outside of your lab. You'll want to take advantage of the uniqueness of being here at the University of Michigan. We have more than 1,000 student groups and societies, so before you start a new student group or society, check the list, see if it already exists. The non-academic interests that take you away from your studies, I think you'll find to be refreshing and inspirational. I won't talk a lot about Ann Arbor, but it is one of the quintessential college towns in the United States. Definitely makes my top 5 list. It is rich in arts, in culture, in restaurants, in entertainment, and of course, Big Ten sports. So a lot to do here. Well, you've reached a milestone. Today should be a really big deal for you. I hope you're feeling that way. Likewise, it is for us. We take your education as a serious responsibility. When I say education, more than just what takes place in the classroom. Although undergraduate students are often the face of a university because there are so many of them, and they are certainly hailed for their school spirit, it is you, the graduate students, who carry out the majority of research on the campus, and that's certainly where we make a big part of our name. Your excellent work will reflect well on the College of Engineering here at Michigan, and it will make a big difference to future generations of students and also to everyday people out there. We thank you for the future impact that you're going to be making, and we hope you have a phenomenal experience here with us. Each of you brings remarkable talent to this campus. That's how you got here. I ask that you make the most of your years here at U of M. I offer my very best wishes for a great start and an enjoyable and productive grad school experience. And if you haven't learned it yet, you're going to learn how to say, "Go Blue." Take care.